Okay, example 10. Aren't you glad that it's almost over? And you get to do more work of it on your own. So let's get into this problem here. And I'll find example 10. And there it is. We'll put the pointer on the screen. Okay. And what you're seeing here, okay, so it says find the value of x that makes triangle ABC similar to DEF. So it's important that over here, I'm just going to put DEF here so we can line things up better. This statement tells you a bunch of information. Most people really ignore it when they see it. That's a lame DEF, so I'm going to just erase. Okay, and take my time here right now. If I'm still pretty bad, it would be worse if I was using a mouse. Okay, so there's DEF. So I know A corresponds to D, and they should be the same if they're similar. So A and D. B goes with E. B goes with E. And then C goes with F. 1, 2, 3. 1, 2, 3. It's hard to see here, but 1, 2, 3. So let's color it in here. And we'll color this one in here, so we know. Okay, so that helps us see what corresponds. Now it's already laid out for us, but you should always do that because sometimes you have to twist the triangles. So 1 to 2 arc, 1 to 2 arc, that means 4 and 12 go together. So 4 and 12 go together. 2 arc to solid, 2 arc to solid, so that means x minus 1 goes with 18. Okay? And then the other one we have is single arc to solid, single arc to solid. So we also know 8 goes to 3x plus 1. Okay? So you can pick, now obviously, I mean, if you want to do it, you can cross multiply these and do it and you get a quadratic. But what I'm going to do is I'm going to solve this proportion, and then I'm going to solve, and I should get an x value, and then I'm going to solve this proportion here. So I'm going to solve these two, that's a 12 there, and then I'm going to solve these two as a proportion. So let me clear this stuff out and we'll do the problem here. So I'll make it a little neater looking on the screen. Okay, and better put this back to a pen, what it is. Okay, so I already know that 4 is to 8. So 4 is to 8 as 12 is to 3x plus 1. So I explained it last time differently. I went 4 is to 12 as 8 is to 3x plus 1. And if you do it that way, so or you could have done 4 is to 12 as 8 is to 3x plus 1. Okay? And when you do that, you get 8 times 12, and here you get 8 times 12, and you get 4 times 3x plus 1. So I don't care which of these you have, they're still going to give you the same answer. So I'm going to get 4 times 3 is 12, and then I'm going to do 12, so I'm going to say, let's just not skip that step, plus 1. And you're going to get 12 times 8 is 96, right? And on this one here, I'm going to get 12 and x plus 1, and this I'm going to get 96. So it's the same thing. It's just set up slightly differently, but you still related everything right. So now we've got to do the rest of the work here. Well, instead of distributing, I'm going to divide it by 12. Save me some work. And that will be 8 equals x plus 1, because these cancel out. And then I subtract 1, and I get x equals 7. So that was using 4 and 12 and 8 and 3x plus 1. Okay? The other way we can do it is 4 goes with 12. So 4 and 12 go together as x minus 1 goes with 18. And again, I set it up differently prior to this, but you're still going to get the same effect here. So I'm going to get 12 times x minus 1 when I cross multiply this. And when I cross multiply this, I'm going to get 4 times 18. Okay? And again, I'm going to choose to divide by 12 instead of distribute. It'll make my life simplifying easier because I don't feel like using the calculator, and some of you don't understand that. But so 4/12 is 1/3 of 8. And so what's 1/3 of 8 is 6. I'm going to add 1 to both sides. So x minus 1. I'm going to add 1. And voila, as they say in France. Oh, it didn't matter which way I do it. It turned out I got the same x's. Now if you want to try it a different way, you can end up getting these two to cross multiply. And you'll get some x squareds, but you'll probably get an answer that you're going to have to throw out. Like that will give you a problem there. So let's check that right now. If I go x minus 1 is to 18, as 8 is to 3 times x plus 1, you're going to get 3x minus 1 x plus 1. You're going to get 8 times 18. And we'll divide the 3 and bring it over here. So so x, this is x squared. The negative 1x and the positive 1x are going to cancel out, or this is a difference of squares, so then you're going to get negative 1. You divide by 3 to both sides. Oh, I can divide the 18 by 3 and I get 8 times 6, which is 48. X squared minus 1 equals 48. I'm going to subtract 48 from both sides. And it's going to give me x squared minus 49 equals 0. And some of you are freaking out. What do I do with that? Well, that's a perfect square. 49 is 7 times 7. And so there's the difference of squares property. And so if you check this, negative 7 times negative 7 is negative 49. X times x is x squared. And x times 7 is 7x. Negative 7 times x is negative 7x. So they cancel out, so I got to there. And so now I get x minus 7 equals 0. That's a 7 there. So x, when you add 7 to both sides, is 7. You get x plus 7 equals 0. You subtract 7 from both sides, you get x equals negative 7. So we just have to check. So the 7 is, we already know it worked even up here. So that's for sure. Negative 7, does that work? Well, if you put negative 7 here, first of all, you put negative 7 here, it's negative 8. So it doesn't work. Okay, but you could have checked it here, negative 7, negative 6, so you get negative 18, which again doesn't make sense for a side length. So this one here, we just is extraneous. We're just going to throw it out. Good night, Irene. We're done. I hope you didn't fall asleep through too many of these examples.